Hello there once again. So today we are going to start off with chapter 5, that is congruence of triangles. So before we move into the cases of congruency itself, we need to understand what congruency means. So what exactly does this congruency mean? So they've given us a definition here. A pair of plane figures which may be made to coincide is called a pair of congruent plane figures. So what does that exactly mean? That if I have two plane figures and if I keep them right on top of each other, they should not overlap. They should not, one should not be, jutting out, or nothing is bigger or smaller. So let's say, for example, like I give you the exact measurements and tell you, okay, so this is my measurement and I want you to draw a square and cut them. So when I like keep both of those figures, let's say two children have drawn it and I cut and get those two plane figures, and when I keep them one on top of the other, none of them should overlap, which means you have two congruent plane figures. Now when it comes to congruency of two triangles, like this will actually form the basic of the proving questions itself. Now when you take your past papers, you will have when you look at the past papers, O-level past papers, they have a lot of questions with proving. At least a minimum of 2 questions would be there. So the basic, or the base of the question itself starts with this congruency. So that is why it's important for you to understand what congruency is and what are the cases of congruency. So we're going to learn about 4 cases in this chapter. Right. So in the first case, they're telling us the case in which 2 sides and the included angle of one triangle are equal to 2 sides and the included angle of another triangle. That is the side angle side condition. So here we have 2 sides and one included angle. This is where, like, we need to stress on more, because the angle should be included, only then we will see that they are congruent. So if you look at this, like, these examples that we have over here, according to the data marked on the figure, prove that the triangles ABC and ADC are congruent. So basically we need to prove that when the triangle ABC is kept on top of the triangle ADC, they do not overlap and they are congruent. So to prove that, we are going to use the case 1, which is side angle side. So we need to prove that 2 sides of the 2 triangles are equal and the included angle is equal. So if you look at this triangle, like the triangle ABC and ACD, the first thing that we can observe is immediately about AC, which is going which is the common side for both the triangle ABC and ACD. It's the common side. That's something that we can easily identify. So we're done with one side. Now let's move to another part of it, where they've given us that AB is equal to AD. So whenever we write something, whenever we write the proof, we need to write how we figured it out. Like that's why they've written AB is equal to AD, and within brackets they've written given, which means the data is given in the question itself. One of the best practices when using this, or when starting off with these proving questions, would be the first thing is to write the data. Like we're going to write 3 things. First we write data, and we write all the data that they've given. Let's say for this question I'm going to write AB is equal to AD, because that's something that they have given in the question itself, and they've also told about the angles being equal. So I can also write angle BAC is equal to angle CAD, and that's all data. And then I can write to prove that, like TPT, we can give a short form there to prove that. What exactly do we need to prove? We need to prove that the 2 triangles ABC and ADC are congruent. So we can write ABC is congruent. You can put the symbol. In this case, the congruency symbol would be 3 lines. Now, like the equal, not equal is with 2 lines, but here we're going to put in 3 lines. So ABC is congruent to ADC. You do not have to write it in words. You can write it using the symbol. And finally, I'm going to put in the proof. So in the proof part, I can write all this, what I'm going to write. This section here can be written in the proof part here. So AB is equal to AD, and then next thing that we can look into is angle BAC is equal to angle CAD, which is also given. Now when they said included angle, what exactly did they mean? Now if you look at this angle here, this angle is in between the sides that they told, or that they had given. Now for example, if they would have referred to this triangle or this angle being equal to this, yeah, they are equal, but the angle is not included in the two sides that we need. So, that is why the problem comes in. That in that case we are not sure if this is congruent or not, because we do not have enough proof to show. So, when they say included, it is going to be this angle which is in between the two sides that we have shown are equal. So, that is where we get the side, and this is the angle, and this is the side again. So, side angle side, and we are done with that question. So, that is how we need to prove, and once we have proved that two triangles are congruent, the next part that we can say is the remaining elements are equal, right. So, we can say that remaining elements of or corresponding elements of congruent triangles are equal. Now, what does that mean? Now, we prove, we had actually shown in our proof itself that AB is equal to AD. But if you talk about the side BC, we did not show anything, but now since the two triangles have become congruent, we can say that BC is equal to CD. And the reason we can write down there is corresponding elements of congruent triangles. That that would be enough when we show that. And then when you look at the angles also, we can say that this angle ABC is equal to angle ADC, because that is the corresponding element. Now, to find the corresponding element, the next thing that we need to know is now to side AC, opposite to this, like this side is opposite to this angle and this side is opposite to this particular angle. So, that is why we say that these are the two corresponding angles. That is how we figure out what are the two corresponding angles. Like some children might mistake to say that this angle is equal to this. It is like clearly visible that they are not equal as well, but in case you have a doubt of how to figure that out, you can always look at the side and the opposite, or you can look at the angle and decide if it is the same side opposite to that angle. So, then yes, that is how we figure out the corresponding elements. Alright, so that is actually an example under side angle side. We have a few questions as well in this case, like I will just pick one question here and try to show you how we can work this out. So, if you look at the question 3 in the given figure, AB is equal to DC, that is already shown here, AB is equal to DC, and angle ABC is equal to angle BCD. So, angle ABC is equal to angle BCD. So, side and angle, both of them they have given, and if you look at this BC, it is actually a common side to both the triangles ABC and BCD. That is where the base actually forms. So, now we have side, we have an angle, we have another side. So, we can say that they are congruent under side angle side. Remember, we need to put the case under which we prove that they are congruent as well. If not, we might not get the entire marks. This usually goes about 2 to 3 marks for these congruent questions, but like I told you, this will form the base to answer all the other questions that follow afterwards. So, that is why this lesson is really important. And if I just pick another thing there, yeah, another question 5, using the information marked on the triangle ABC, prove that triangle ABX, so ABX is this one, and triangle CBX is congruent. Once again, it is the same thing over here. We have the two sides that they have given, we have the angles that they have given as well. They have told that it's bisecting. So, yeah, we can say that angle are equal, these two angles are equal. And finally, we can also say that BX is a common side. So, side angle side. Okay, now in this case, they have told us to prove that AXB is equal to 90 degrees. This is something that we need to think a little bit. So, if you look at this part, we know that based on congruent triangles, once we say that two triangles are congruent, we told that the corresponding elements of congruent triangles are equal. So, if you look at to this side, this is the angle. So, angle BXC is equal to angle BXA. These two angles are equal. So, let us say that I took these angles as y. I have 2y and this is a straight line, AC is a straight line. So, we can say that 2y is equal to 180 degrees. The reason why 180 degrees, angles on a straight line, because angles on a straight line are always equal to 180 degrees. So, angles on a straight line, that is why we have written that. So, if 2y is equal to 180, 1y would be equal to 180 divided by 2. So, y is equal to 90 degrees. So, y is basically, in this case, we labeled the angle AXB as y. So, that is what we got, that is how we get that answer there. So, I hope the first case is clear to you and there are no questions under that. So, now we will be moving on to the second case itself. So, in this case, the second case that we are referring to is going to be the angle side or the AAS side, right. So, in this case, if two angles and a side of one triangle are equal to two angles and the corresponding side of another triangle, then the two triangles are congruent. So, in this case, like in the previous case, we had two sides, one angle. Here we are having two angles, one side. But another part that I need to specify here is we are not referring to included side here. Like in that case we said included angle, but here the side is not included, but it has to be corresponding. Now, what does that exactly mean? Now, if you look at this diagram that they have given, they have one angle here, it's equal, angle U is equal to angle L, angle T is equal to angle N, but ST is opposite to this particular angle, but not included between the two angles. If they would have said included, that would be like, it should have been in between the two angles, that is UT, but that's not what we are referring to. It does not have to be included, but it has to be corresponding. Now, if the side that they have given is opposite to this angle on this triangle, then on the other triangle also it has to be opposite to the same angle, because U and L are equal. So, that's one thing that you need to understand, the difference between side angle side and angle angle side. So, let us move to the examples. I think this is like an okay chapter. We can, if we understand it clearly, I think it's definitely going to be really easy. But for a beginner it might be a little bit tough, because this is where proving comes into, comes really into the questions itself. So, let us look at this example given. Based on the data marked on the figure, prove that triangle ABX is equal to triangle, is congruent to triangle ACX. Now, in this case also we have like data given. Most of the things are data that they have given, that ABX is equal to ACX, data given, and on the other hand they have told that BAX is equal to CAX, that is also data given, and AX is a common side. So, two angles, one side, are problem solved under the case angle angle side. And then if they ask you to show that all the remaining equal corresponding elements, you have to show that AB is equal to AC, and then we have BX which is equal to CX, and the remaining angle, that is going to be AXB is equal to AXC. So, that is about that part as well. So, in this also we can look into one or two questions there. So, let's look at the triangle question 5. In the triangle ABC, ABC is equal to 90 degrees. So, this is also 90 degrees. Here we go. If AF is equal to BC, AF is equal to BC, prove that triangle AFG. So, AFG is congruent to triangle BCE. Okay, now we have a little bit of a different question over here, right? So, we can say that now we need to see how we are going to prove this under angle angle side, or sorry, side angle side here. Yeah, not side angle. Let's say it's actually angle. We're doing the lesson. We're doing the part with angle angle side. So, that's the questions there. Let's see how we can apply angle angle side there. And yeah, so question 5 comes in here. The first thing that we have is the data AF is equal to BC. So, make sure that you write in triangle AFG and triangle BCE, and then start writing your answers. AF is equal to BC, one problem sorted, one side we have got. Now, we need to think about the two angles that we have. Okay, so let us take it this way. If I am going to label now angle A as X, I am going to label angle A as X, right. So, if I'm going to look at the triangle AFG. Now, if this is X and this is 90, this angle here would be 90 minus X. Okay, now why is it 90 minus X? From where did we get a 90 minus X is another question that can come up. Now, we know that angles in a triangle should add up to 180. So, if this angle is 90, which means the balance two angles should be 90, because 90 plus 90 gives us 180. Now, I have labeled this as X, which means this is going to be 90 minus X, right. Now, let us look at the triangle ABC itself, the bigger triangle. If you look at the triangle ABC, this is 90 degrees, angle ABC is 90, and this is X, which means this angle is also going to be 90 minus X. So now let's look at the question that we had. We proved that AF is equal to BC, I mean that's the data given itself, and we also were able to, I mean we can also say that AGF is equal to BEC, because if this is 90, this side is also going to, I mean this angle is also going to be 90 degrees because it's on a straight line. So these two are equal. Now the next thing that we can actually prove is if this is 90 minus x. Now we showed how why this is 90 minus x. So we can say angle AFG is equal to angle ECB. So now we have two angles and one side, so we can say that this is congruent under angle side. I hope that part was clear to you and you have no questions based on that. That's pretty much it. I mean this is a little bit of a tough question compared to the rest, because you need to figure out that this is 90 minus x to show that two angles are equal. So to do this, like if you look at it in depth, you have to remember your previous theorems as well. You have to know that angles in a triangle, they sum up to 180 degrees. So things like that are essential. Where like in the latter part of these videos itself, I'll do an entire theorems like like a recap of all the theorems that you have learnt as well. And like let's move to the third case. I'll just clear this off before we move to the third case. In the third case, we are going to refer to the side or the SSS case. This is like a pretty much simple case. When all three sides of one triangle are equal to all three sides of another triangle, then they are congruent. Like I told you, that's how we usually draw triangles, like when the measurements are given, that these three sides are given, and two children draw that, then definitely if they've drawn it correctly, then definitely they're going to be congruent. So if three sides of one triangle is equal to three sides of another triangle, we say that they're congruent under SSS. So if you look at these two triangles over here, we need to prove that triangle PQR is congruent to triangle PSR. So here they've given us the details here, that PQ is equal to RS here, and on the other hand they've told us QR is equal to PS. So another mistake that children commonly make is now on this side we are actually referring to the triangle PQR's details. So everything comes here, all PQ, then QR, and on the other side we are referring to the details of the triangle PSR. So let's not, like if you write PS is equal to QR, it's not wrong, but like it's a best practice to do, to write one triangle's sides on one side and the other one on the other. So that's like a good practice that we can say. So yeah, coming back to the question, like PQ is equal to RS and QR is equal to PS. Both of them are given, and then PR is a common side, so they are congruent under SSS, and the corresponding elements basically means the remaining angles will be equal as well. So the reason would be corresponding elements of congruent triangles. Moving to the questions, I think these questions are pretty straightforward itself, that you have the opposite sides of the quadrilateral PQRS are equal, prove that these two are congruent. It's the same thing, the two sides are given, like RS is equal to PQ and PS is equal to RQ given, and RP or PR is a common side, so no problem with that. They are congruent under SSS, and then PSR is equal to PQR. So PSR, that's this angle, is equal to PQR, that's this particular angle. So both of them also we can say, like we can just write this and within brackets put that corresponding elements of congruent triangles. And then the last part that, or the third part that comes in, is the opposite sides of the quadrilateral are parallel. Now to do this, there are actually like many ways that we can prove that the opposite sides of the quadrilateral are parallel. So one thing that we can put in is, like let's say for example SRP opposite to this side, and opposite to this side is this angle here. So if you look at this, SRP is equal to QPR. Why? Corresponding elements of congruent triangles. Now if you look at this part, it's actually forming an alternate angle. So in parallel, I mean when you talk about like parallel lines, there are three types of angles that we refer as well: alternate, corresponding, and allied. Alternate is when you form the Z angle here. So in this case, it's forming an Z angle. So we can say, since we have an alternate angle formed, the two sides SR and PQ are parallel. Likewise, so we don't have to show the same thing for the other two sides. We can just say that therefore likewise I mean, likewise would be a better term there, or similarly, even that you can use. Similarly, SP is equal to RQ, or SP is parallel to RQ, because that's what they've asked us to do. So, you can also, if you want, you can use the corresponding angle theorem, or this is, I mean, alternate angle here is the easiest way to figure it out. But yeah, you can, I mean, finally say that this is a parallelogram as well, because opposite sides are equal and parallel. So, it's a parallelogram basically. So, moving to the fourth case, or the last case in the congruency lesson itself, that is the RHS, right angled hypotenuse side. Right. So, in this case, if the length of the hypotenuse and a side of a right angle triangle, so specifically right angle triangle, this can only be applied to right angle triangle and nothing else, are equal to the lengths of the hypotenuse and a side of another right angle triangle, then the two triangles are congruent. So, you need to have two right angle triangles, that is basically 90 degrees, and then the other thing that they should be equal is the hypotenuse. The hypotenuse means the side that is opposite to the 90 degrees. So, to this 90 degrees it is PR, and to this 90 degrees it is AC. So, that has to be equal, and any other side, it can be either AB, like, it can be this way. So, here AB and QR are equal. So, any other side should be equal. So, if that three conditions are met, then we can say that they are congruent under RHS, or right angled hypotenuse side. So, looking at this example, we have a circle, we have the center O, and we have a triangle there, two triangles there, that is OXA and OXB. That is what we need to prove are congruent. So, this is 90 degrees, basically means this is 90 as well, because AB is a straight line. So, we have two right angle triangles, one condition is met, and OX is a common side, another condition met. And now we need the third thing should be the hypotenuse should be equal. So, hypotenuse in this case is OA and OB, they are equal because both of them are radius of the circle. Now, what is a radius actually? Radius is if a line is drawn from the center to the circumference. So, center is O, circumference is this part here. So, the line that is drawn is OA and OB, so they are equal. Reason would be radii of the same circle. So, therefore, both of these triangles are congruent under RHS. Now, the reason why they have not actually written OXA is equal to OXB is because they have specified in the right angle triangles in this part. So, when you specify that they are right angle triangles, you are actually confirming one of the conditions at this point, and it's met. So, there is no problem with that. So, basically those are the four cases there, and we have an exercise related to that part itself. So, looking at one of the questions, if AC is equal to PR, so let me just mark that if AC is equal to PR and AB is equal to RQ, okay. So, AB is equal to RQ, show that BP is equal to CQ, okay. That is a little bit of a different question. We need to show that this and this are equal. Now, first thing, like I told you, this forms the base, the congruency forms the base of the question itself. First thing that we can see is triangle ABC and triangle PQR are congruent, both of them they're congruent. Reason, both of them are right angle triangles, one condition met, hypotenuse is equal, second condition met, sides are, one pair of side is equal, so third condition met. Now, when we say that, the next thing that we can come into a conclusion is BC is equal to PQ. Now, we referred to saying that the corresponding elements of congruent triangles are equal. So, to the triangle, if I am drawing these two triangles separately, this will be my triangle ABC. So, let me just quickly draw that. This is my triangle ABC and this is my triangle PQR. So, it is somewhat the same thing, alright. So, in this case, if I am going to label them as well, this is A, B and C, and P is here. PQR is here, and we just have a few parts as well, where this point we have a BP, and somewhere around here we have a C. C and this is P. So if I am supposed to apply, like, the corresponding elements of congruent triangles, I can basically say that BC is equal to PQ. But the question that is, what we are supposed to be doing is to show that BP is equal to CQ. So BP is this part here is equal to CQ. That's what we need to prove. So for that, we know that BC is equal to PQ. BC is equal to PQ. So if you look at this triangle, we have one small section which is common, right? That's basically, we have this PC, right, which is common, because when you join them, you know that PC is a common side. So from both BC and PQ, I'm going to subtract PC. So BC minus PC equals PQ minus PC. Now this is where your grade 9 axioms lesson comes in. So if you if you want, you can refer to that grade 9 lesson as well, where axioms, we say that if A is equal to B, and if I subtract C from it, A minus C equals B minus C. I can subtract the same thing from the equal values, right? So BC minus PC. So from this line, if you look at the diagram, from the line BC, I'm subtracting this PC. So I'm left with BP. So that's how the BP comes in there. We're done with one part. And on the other hand, from PQ, we're subtracting PC. That's this part. So we're left with CQ. So the second part section is also met. So therefore, we can say, to show therefore, you can put 3 dots together. If I being specific about the 3 dots, one and then like a triangle dots. Yeah, this is the dots that they use for therefore as well. So you can use that if you want to, and then we can write therefore BP is equal to CQ. All right, so that's the way you can work out this question as well. That's for question 3, the answers there. So like I told her initially, we have 4 cases that we need to be very thorough with, and the 4 cases would go as side, angle, side, angle, angle, side, 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 and RHS. So if you are if you are confident with this part, the rest of the proving questions also will become really easy for you. So I hope that was clear, and that's pretty much it from this chapter. So if you do have any questions, please make sure that you email the questions to me, and don't forget to like, share, and subscribe. Thank you. Bye.